Wow. Summarizing bivariate categorical data in a two-way table. You know what? Honestly, when I looked at ADM6 lesson 13 and saw the title of this lesson, I was confused myself. It's very hard to tease out all these words and exactly what they mean, but hopefully we can make some sense of those today, and you will find that this is actually pretty fun and powerful math to learn. And we'll be doing this today and tomorrow, and we'll be done with the year. This is really cool. This is really the beginning of statistics and understanding how to use statistics in a very relevant way to see if two things interact or two variables affect each other in poles. So this is different than when we're not going to be doing graphing of lines and looking for linear correlations. Instead, what we're going to be doing is simply building tables of information, calculating some percentages, and looking and seeing if those things are, if the two variables tend to correlate to each other. So if I'm a boy, if we look at favorite ice creams in class and we look at boys and girls in class, do boys and girls tend to have the same favorites or not? If we have, if we look at a group of 5th graders and 8th graders and whether they do their homework on paper or on computers, does it tend to matter or not? And we need to put together lesson 13 and lesson 14 to fully be able to answer this question, but we need the building blocks here in lesson 13, which in fact count on building blocks from 6th and 7th grade on how to calculate percentages and read tables. So this is a cool lesson. Let's get going and see what we can learn today. Okay, so let's move on to some terms that we need to understand. And this is basically univariate and bivariate data. And we've actually talked a little bit about this, but bivariate data is when we talk about variables or data that has 2 dimensions or 2 variables. And that's, you know, we've done a lot of that when we've done our XY graphing, when we've talked about, you know, time and distance. So we talked about our our X and Y graphs, where after a certain amount of time, we've gone a certain amount of distance. That would be bivariate data. We're going to start off right now with univariate data and putting that in tables, and then we're going to move on to bivariate data today. So we'll give an example really quickly over here in this reddish pink thing, this example, and we'll talk about some univariate data, okay? But also as an overview today, we're going to look at summarizing each type of data in tables. So we're going to start off with summarizing some univariate data in tables. We're going to calculate some percentages or frequency, what they call frequencies when we're talking about statistics. We often use the word frequency instead of percentage. And then we're going to answer some questions based on our calculations and our percentages and such. So this should be, I really hopefully you have fun as we end the year. I really like, a lot of students really love statistics, and if you have a knack for statistics or you love statistics, it's a kind of math that you can actually make a lot of money in the world and have a lot of fun in your job in. There's many different areas of the real world where statistics are extremely important. And even if you're not in the field of statistics, knowing how to read statistics when you look in the newspaper and some politician is trying to convince you of something, it's good to know how to do the math yourself to see if they're just pulling the wool over your eyes, which sometimes unfortunately happens in this world. Okay, so let's move on to our example. So over here in our example, we want to understand trends of what device students like to use to browse the internet. Okay. So when you're browsing the internet, I created this poll and asked all my 8th graders, and there were 75 of them, 75 total. And I said, do you like to use computers, laptops, tablets like iPads or Surfaces, Surface Pros, things like that, or phones? What is your preferred, which one do you like to use to browse the internet? And so I created this poll, and I gave a piece of paper to all the students in 8th grade, and they would check computer, or they'd check tablet, they'd check laptop, and I collated all of this data. So I had 75 answers, and I put them in a tally chart. So we'll move over to the next page where we look at the data that I received. Okay? And so here's what we got. We got, this is my tally chart. So I have 25 students who preferred computers. They like browsing on computers. On laptops, I got 10. I got 17 that preferred browsing on laptops. On tablets, the fewer, 13. And then on phones, I got 20. Now my total, again, because here, let's just put these down. So how can we add these together quickly? Who can see that? Who can see how to do this in your head? Well, here's how I'm going to do it in my head. I see, well, that's 30. And that's 45. So together I have 75. Notice I didn't have to, come down 12, 13, 5. I didn't have to do any of that because I used some quick math to group some easy numbers together and come up with 75 total. And I knew that should be the answer because I asked 75 students. But you always want to sometimes double check, or you always want to double check and make sure that you got the right numbers. Okay, so we've built our table. Now what we want to do is we want to calculate what we call our cell frequency. And a cell frequency is the cell value divided by the total. And then you write that as a percentage. So let's go ahead and calculate those cell frequencies in this table. So I'm going to, what is my total? My total is always going to be 75. So my cell value here is 25 divided by 75. So I'm just going to write that here, 25 divided by 75. And so that equals, and I can do that one in my head. Here, let's do it in a different color just so we can really call it out. So that's 30, and I'm going to round to the nearest percent. So it's 33.333%, but I'm going to round it to 33%. Now let's do the next one, 17 divided by 75, and I'm going to do it on my calculator. And so this is rounded, is 23. I'm going to write it as clear as I can, 23%. 13 divided by 75 is 17%. And 20 divided by 75 is 27% rounded. All right, good. So now we have our percentage. If we add up all these percentages, I can tell you 60, it should add up to 100. Sometimes because you round, it might add to 99 or 101. But in this case, we have 33 and 27 is 60. And then 23 and 17 is 40. So we do get 100%. So we should always have 100% when we are really close to 100%. And if we don't get 100%, we can round to the nearest tenth. And then we should be getting closer to 100%, but let's not worry about that too much. Okay, so let's answer some questions. What is the favorite device? Well, which one has the highest count or the highest percentage? Well, our favorite device seems to be, well, it looks like computers. We have the highest number, 25, and we have the highest percentage, which makes sense. So computer is the favorite device. So if this is a good sample of 8th graders, and there are 1,600 8th graders in the school district. So now we're not just looking at our school, we're looking at the entire school district, which might comprise, 20 schools or so. I'm just making that up, might be 20 schools. How many 8th graders prefer using phone to browsing the internet? So let's see. Well, we have to go back to our knowledge of percentages. So we're going to assume that this is a good sample. And so we assume that 27% of 8th graders prefer to use the phone. So let's see. So 27%, so that's 0.27, of is times 8th graders. And there's our math. So we have 27% prefer using phones. So we would say 0.27 times 1600. We'd multiply that out and we get 432. So we would estimate 432 students prefer the phone for browsing the internet. Okay, and you can figure out what percentage of students would prefer laptops or tablets. So I want you to right here tell me, and I want you to pause and try. And what percent or what number in the district prefer using laptops? So this is what number prefer laptops? So I want you to calculate this here. I want you to pause and try. Okay. Now I assume you're back. And so the way we find it out, what percent prefer laptops? Well, of 1,600 8th graders, it's 23%. So 0.23 times 1,600, and that equals, I'm going to my calculator. Your teacher may not allow you to use calculators, but if you did the math and you wrote it out, the answer should be 368 students. All right, now that's pretty interesting stuff. We can build these these univariate tables, but now we're going to go and let's ask one more question, and we're going to use this same data, but we're going to, what they say, tease it out in another dimension. So what question might you ask? In what way might you divide these students to get more data? Well, I've already suggested that you could have asked it, we could have said, well, we could have said 6th and 8th graders and had a new poll. But of these 8th graders, I'm going to divide by girls and boys. So watch what happens. So I created an additional poll. Notice what I'm doing here. I gave another poll where I said, well, I prefer computers, laptops, tablets, or phone. But then I also, on that same piece of paper, I said, I am a girl or I am a boy. So notice what we did. We now should have the same total that prefer computers, because 25 students preferred computers, 17 laptops, 13 tablets, and 20 phones. But I got more data here. And so when I did my tally, I found out that of the kids that like computers, 13 were boys and 12 were girls, for the total of 25 that preferred computers. For laptops, I got 9 boys and 8 girls for my total of 17. Tablets, I got 7 boys and 6 girls. On the phone, though, I got 16 and 4. And notice in my class, so if we add across, so girls, if there's 12 and 8, that's 20, and 6 and 4, that's 10 more. So there's 30 girls in my class. And boys must be 45. It must make the difference. And we can add that up. 13 and 9 is 22, plus 7 is 29, plus 16 is 45. So I have a lot more boys in my class than girls. But here's my table, and it makes sense. So I can add across here, and I can get my 45 boys. I can add down here and get my 17 laptops. I can add down here and get my 13 tablets. I can add down here and get my 20 phones. Okay. So the neat thing is if you add down columns, you can get the total at the bottom. If you add across the entire row, you can get the total here. And further, if I take my totals of boys and girls and add down, I get my 75 total kids. Or if I add across my preferred device, I get my 75. So this is really cool table. It has a lot of power in it. It shows a lot of numbers, but they all tie together if you add them, you know, across the row or across the cell. We'll be doing another example of this, and this is really, you know, we're really to the homework help section because everything we're doing from now on out, you will see on your homework. Building these tables and calculating percentages, okay? Now, I want to introduce the concepts of row relative frequency, column relative frequency, and cell relative frequency. And these are going to be 3 different numbers for each cell. So I can find the row relative frequency. I'm looking just at a row. Okay? And so what I'm going to do is I'm going to take my cell value, all of my cell values, and I'm going to divide them by my total. Okay? So my row relative will be 13 divided by 45. And so that's 29%. So let's just go through this exercise really quick. Let me do this in a different color. We'll do our row here. So that's 29%. So we'll do our row relative frequency. 29%. 9 divided by 45 is 20%. 7 divided by 45 is 16%. And 16 divided by 45 is 36%. Okay, so of boys, so the way we read this row relative thing is we're just talking about our boys. So of the boys in the class, 36% preferred phone, 29% preferred computers, then laptops, then tablets. So boys have a preference for phone. Now let's do the girls. So we're going to not divide by 45. Now we're going to divide by 30. So let's take 12 divided by 30, and we get 40%. 8 divided by 30, and we get 27%. 6 divided by 30, that should be 20%. And then 4 divided by 30, and we get 13%. Okay, so that's how we do those calculations, and we can ask some pretty cool questions about this. So right off the bat, we can say boys. Let's see. Well, overall, computers. Remember, we calculated that computers were the most popular just overall. But boys seem to prefer what? Boys prefer phones. Girls prefer computers. And then the next thing girls prefer is laptops. Then laptops. right? So girls prefer, right? They prefer computers first. Laptops is the second biggest number. Boys prefer phones, but then they prefer computers, right? And it's kind of weird because in the class as a whole prefers computers than phones. As a whole, they prefer computers than phones. So what do you think? So the question is, do you think that it matters which one, if you're a girl or a boy, is it different? And the answer is yes. It appears that boys and girls have very different preferences. And so that's what this chart will show. Now let's move on to the next. We're going to stick with this same data, and I think I'm going to actually ask some of these questions, but we'll ask some different questions on the next page. And this is very powerful stuff, right? You just ran a poll, and you can really quickly see with these numbers, these big numbers, and then maybe you also look at your smallest numbers, and you see that there's that they're very, very different. Okay, so let's move on. All right, we already asked these questions. So these are the same. This is the same type of question. Remember, this was 20. These are our row relative frequencies: 29%, 20, 16, and 36%. And we had 40, 27%, 20, and 13%. So we already answered these questions, and this was 36%, and this was 13%. And we actually went and explored some of this question. We did question number 3. Do boys and girls seem to have different preferences? And the answer was yes. Yes. So here's my new question. Calculate how many boys out of 1,000, and this is homework help. How many boys out of 1,000 would prefer phone? Well, we kind of did a problem like this, so I want you to pause and try. I want you to pause plus try. Number 4. How many boys out of 1,000, if 30% prefer phone and 13% were girls? Okay, so I assume you're back. So let's see. Out of 1,000 boys, 36% of boys, of all boys, that'd be 0.36 times 1,000 equals 360. Prefer phone. And for girls, it would be 0.13, 13% times 1,000. So now you see why we calculate these percentages, because percentages make it easy to convert to other values. If we have larger and smaller sample sizes, we can make predictions. 130 girls prefer phone. And these are our estimates, because when we're dealing with statistics, we're dealing with probabilities and estimates. We can never be exactly sure. If I chose 1,000 boys, it's highly unlikely that exactly 360 would like phone, but probably about 360 would prefer phones. So let's ask the final question. For students preferring computers, what percentage are boys? Okay, so this is a different question, and I'm going to give you a hint. And this we're going to need to use column relative frequencies. So instead of using the percentage using this total, we're just going to look at the column and calculate percentages using this total. Don't get confused. So let's see. You can now I want you to pause and try. So you are going to ignore all of this and you're just going to look at this. So pause and try, and then we're going to work it together. Okay, now I assume you're back. So let's do it. So this is our total, 25. So of boys, I'm just gonna take the table over here and I'm going to get rid of everything else because nothing else matters other than this one column. 25, 12, and 13. So over here we get 13 over 25. And over here we get 12 over 25. And so this is 52%. And 12 over 25 is 48%. So of students preferring computers, about half of them are boys and half of them are girls. Because here we're just looking at this population. Okay, very good. Now what I'm going to ask you to do is one final question. Let me guide you through it before you start working it. It's a lot on here, but I want to understand. So here's my question. Here's what I'm wondering. I'm right here. I want to understand the relationship between students owning cats and dogs. So I want to perform a poll. I want to see if students that own cats are more likely to have dogs or less likely to have dogs, or just what the breakout in my class is. So I perform this poll here, and I hand this to all my students. And so the students have to answer the question, I have a cat or I have a dog, and you could say yes, yes, or you could say yes, no, or you could say no, yes, or you could say no and no. All right. And what I get, my results are students that have a cat and a dog is 10. The students that only have a dog and no cat is 20. Have a cat only, no dog is 15. And have neither is 5. So what I want you to do is fill out this bivariate data chart with my answers. And then I'm going to ask you, wait, let me ask you another question too while I'm at it. You know, how many students are in the class? This is like A1. How many students are in my class? And then what percent, and then E is how many students have a dog? Okay, I want you to now to answer those questions, and then I want you to answer the question, what percent of students have a cat and a dog? Of the students with a dog, what percent have cats? Of students without a dog, what percent have cats? And then how many students have a dog? So you're going to need to, in some cases, look maybe at a row relative frequency, sometimes a column relative frequency, sometimes answer with a total. You're going to have to think about how to fill out this chart and answer these questions. I need some critical thinking skills, and I want you now to pause and try. Pause and try. Give your best. Okay, now I assume you're back. Let's work this in purple. Okay, let's put the data from the results into my chart. Let's get A done. So have a cat and a dog. So we have a cat and we have a dog. That's 10. Have a dog only. So we have a dog and no cat. That's dog and no cat. We have 20. Have a cat and no dog. That's 15. And have neither a cat nor a dog. That's 5. Now let's fill out these totals and let's check and see what we get. So here we have, we should be able to add across to get our total. So we have 10 and 15, that's 25. 20 and 5 is also 25. Adding down, 10 and 30 is 10 and 20 is 30. 15 and 5 is 20. And now if we add across and we add down, we better get the same number. 20 and 30 is 50. And then 25 and 25 is also 50. So that checks out. So that's good. So now we've drawn the bivariate data is a data chart. So we've done this. So how many students are in my class? How many total students are in the class? Well, we know that that's this number. That's 50. Because we have 30 students have a dog, 20 don't have a dog, so that's 50. Or we can look at it the other way. 25 have cats, 25 don't have cats, so it's 50. So our answer is 50 students. So we have 50 total students. Now let's jump down to question E here. How many students have a dog? Well, we can look at the total column here for has a dog, right? So 10 of the kids that have a dog, 10 have cats, 20 don't have cats, but 30 total have a dog. That should make sense, right? They have a dog and have a cat, or 10, that's 10, has a cat, has a dog and does not have a cat, that's 20, so that's 30 total. Or you can just look at the very bottom. Okay, now what percent of students have a cat and a dog? Well, that's a cell frequency, right? Of all students, what percent? You got to look at this of all. You can put in this hidden word all. What percent of all students? It's not saying what percent of students with a dog have a cat and a dog, or what percent of students subgroup. It's of all the students. So of all the students, we have 50. 10 have a cat and a dog, so 10 over 50, that's our cell frequency. That's 20%. Okay, now we want to say of students with a dog, what percent have cats? So what are we talking about? If students with a dog, we're taking a subset. We're not talking about all students anymore. We're talking about of students with a dog. So we have to look at this column and this column only. So in this column, we have to take our cell value over our total. So our cell over our total for the column is equal to, of students with a dog, what percent have cats? Okay, well that's 10. 10 have cats over our total. And so that's equal to 33%. All right? 30 students have dogs, and of those students, 10 have cats. So 10 out of 30, or 33%, have cats that have dogs. So of students without a dog, what percent have cats? So let's look at this. So now we're looking at, let's switch colors. That's this column. So of students without a dog, that's 20 total. What percent have cats? Well, 15 have cats. And 15 out of 20 is 75%. Okay. So the question is do we think that that if you have a dog, does it correlate to having a cat? Well, I think you can think about the answer, and you can think about it in terms of answering C and D. If we have a dog, are we likely to have a cat? And if we don't have a dog, are we likely to have a cat? And the answer is, if we have a dog, we're much less likely to have a cat. And if we don't have a dog, we're much more likely to have a cat. So we think there's probably a relationship between having a dog and having a cat. In other words, if we have a dog, we probably don't have a cat. And if we don't have a dog, then we're likely to have a cat. But in next lesson, lesson 14, we're going to be able to answer that question more definitively. What I'm going to do right now, though, is I'm going to lay down happy cats for getting these answers right and drawing the right bivariate data chart. This is what your homework's going to look like. Hopefully this was useful. Hopefully this is a good example. We're going to go back tomorrow, and we're going to, as we talk about lesson 14, the last lesson of the year, we're going to come back to this data, and then we're going to do another couple examples and see if we can really make sense of some of this statistical data and showing correlations between bivariate data. Okay, that's it for now. Let's go back to the Hangout. We'll say goodbye to me. Bye-bye, me. Summarizing, hopefully this all makes sense to you now. Summarizing bivariate categorical data in a two-way table, all those words hopefully make a lot more sense than they did 30 minutes ago. Thanks for listening. Hopefully you have a great day. Talk to you later. Bye-bye.